start talking to you about application performance, it's probably worth talking about why it's important, and in some cases why it's not important. There's a couple of reasons why we might care about performance. The first is that we might want to increase capacity. Increasing capacity is something that we can do by increasing performance because it means we can move on to serving the next request quicker. It's also a problem that we can solve with scaling. And by scaling, we can scale horizontally by adding more resources to our servers, or we can scale horizontally by adding more servers, or we can scale vertically by adding more resources to our servers. These options are generally quite cheap if you have your application designed properly. Horizontal scaling is quite cheap. Vertical scaling is often a lot cheaper than developer time. But one thing that you cannot solve with scaling is user experience. And that's if you have a genuinely slow application, scaling that application, you'll still hit the limit, but you still have to do a lot before you can return a response. Improving efficiency is one of the only tools that we have for solving the problems of slow response times. And that may or may not be a problem which affects you. Thinking about performance, we have to think about it in terms of efficiency, because in web development, they're very much the same thing, at least for the scope of this talk. What we really need to do is minimize the amount of work that we're doing to create a response. It sounds simple, but it's important to lay it out like that. What we need to do is reduce the number of operations that we're performing between the time of accepting the request and returning the response. What I'm going to use to demonstrate how we can be more effective in this is an analogy. And it's quite a simple analogy, and I want you to all sort of bear with me on this one. What we're going to do is we're going to imagine the HTTP web pipeline, but we're not going to imagine it as we usually do. We're going to imagine it as a restaurant. So I want you all to just have a look at that slide for a second and just work out in your head what you think each of these different things will be. We have a client, a server, the request, the response, application, and the HTTP daemon. So accepting shout-outs from around the room. What do you think the client will be? The client? The customer. That's the simplest one. The client is the customer coming into the restaurant. The server. Ooh, see, no. I've considered the server as everything that the application and the daemon runs inside. So in this analogy, the server is actually the restaurant. The request? Yep, the food order. The response? The food. The application? Now we're on to the chef. And the HTTP daemon that takes the order to the application and returns the food? The waiter or the waitress. That is the first part of our analogy. So now we're all thinking in terms of HTTP as a restaurant. Let's imagine restaurant PHP. This starts off pretty simple. The customer enters the restaurant. Everything's pretty normal here. The waitress takes the order from the customer. We're still within the confines of normality. The waitress creates the chef and gives the order to the chef. This is where things start going off track a little bit. The chef makes the food, at least that's normal. The waitress gives the food to the customer, and the last and the most important part is that the waitress will then brutally murder the chef. Now, can you see how if we were a restaurant manager, we could improve this process? The alternative talk title and my proposal to you all is simply, don't kill the chef. Which, when you phrase it like that, doesn't actually sound like too much of a dramatic proposal. A little bit of a history lesson. This is going well back beyond my time. Who's ever made a CGI application, an application in CGI? Yeah, very good. CGI is basically an old way of telling a web server about your application. We don't really need to tell our web server about our application because mod PHP or PHP-PM does it for us. But CGI was a common portable way of telling the web server about your application. The simple principle was that the application was executable by the web server. you would have an instance of your application per request. So every time a new request came into the web server would start your application, and then once it finished the response, your application would quit, and it would make a new application for the next request. The request was provided by environment variables, so that's what you see in the server superglobal array, which we're not supposed to touch anymore, but it's there if you ever look at it. It's the, remember back in the old days of the superglobals with request underscore URI and remote underscore adder? They're all CGI environment variables that were provided to any CGI application. And the response to the standard output, which is just what you'd echo in a PHP program or print in a different program, would be the web response. And back in the day when I was 3, that's all PHP was. You can still run PHP as a CGI program. You can get PHP-7 CGI. But that was the first version of PHP. It was just a set of C scripts that would interpret other scripts and interface using CGI. Since then, we've come a long way. We can use native web server modules. And another thing that we can use is PHP-PM. Now, what these two do differently is they keep PHP alive between requests. So back with PHP-CGI, you would need to reload the PHP interpreter on every new request, and that was very expensive, as we can imagine. But what PHP-PM and the web server modules allow you to do is actually keep the PHP interpreter alive between requests. And when I first started doing this talk and talking about FastCGI, a lot of people sort of said to me, oh, I don't need to worry about that, I already use PHP-FPM. And that's not what this is about, because we're actually still killing the chef, we're just not destroying the waiter in the restaurant as well. And what I want to talk to you about is keeping Symfony alive between requests. So not just PHP, but your actual Symfony application. And how might we do that? Well, does anyone ever remember writing code that looked like this? Oh, come on, more hands than that. I was doing that about 2 and a bit years ago. That is sort of how a lot of legacy applications that I used to write looked. You'd include some libraries, you'd sort of make your database query, and how would you turn that? How would you keep that application alive between requests? You can imagine it would be quite difficult. You could probably do it with output buffering, but you're going to have problems because headers could be sent out sort of from any point in the script as and when you thought it might be a good idea, like when you needed to do a redirect or something. And generally, that is not a very easy application to turn into a server. Symfony's different. If you've ever looked inside the web directory and looked at the app PHP file, that's your front controller, you'll have found code that looked a lot like this. And what this does is it creates an application, which is the kernel variable in that snippet example. It creates a request from the superglobals array. That's get, post, server, all of those lovely features. And then what I think is the most important line in the entire framework, which is kernel handle request gives you response. And what Symfony has done is it's organized your entire application into a function, because that's all that your application is. Your application is a function which maps a request onto a response. And that's what Symfony very neatly summarizes in that line. Kernel handle request gives response. You can then send the response, and then there's a terminate event, and all that terminate event does is that sometimes, for example, in Symfony when you send an email, you don't actually immediately send that email, because then you need to wait for the email to finish sending before you could return your response. So if you're using SwiftMailer, what's very common is you'll send an email, and then it will wait for the terminate event before it actually does it after the response has been sent. And that allows you to return a response a lot quicker. And it also causes a problem if you ever try and do a worker, or you have like a long-running process and you want to send an email. You're like, why aren't all my emails sending? And then you Control-C your worker, and then suddenly 20 things appear in your inbox. That's because you haven't called the terminate event, or you've set up SwiftMailer wrong. So turning Symfony into a server, there's a couple of options that I'm going to talk to you about. The first one is an application, or it's like an organization in a way, called PHP-PM, standing for PHP Process Manager. And what that'll do for you is that'll turn Symfony into a HTTP server. So it turns it into a web server. It's got some very nice features. It's based on React PHP. You can't actually utilize all of the benefits of React PHP because your Symfony controller still blocks. So React PHP will allow you to create a kind of application where you can be handling multiple requests at the same time whilst you're waiting for your application to finish doing what it's doing. You can't do that with Symfony because it's request in, response out. You can't return a response promise, you can only return a response. So React PHP allows you to utilize faster event loops, but you can't get the full benefits of an asynchronous framework. It also has a process manager, so it will manage and keep alive your workers and reset them when you need to. It can work as a load balancer, which means that you can say, I've got 10 workers, which I want to proxy request between. If you were ever doing it in production, you would never really use those features. You would almost certainly use something different for load balancing. Nginx would be much faster as a load balancer. It has a feature called hot code reload, which means that it'll detect when your files change and then automatically reload your application, which is quite useful. And it will also do static file serving. Again, in the wild, in production, you would definitely consider your web server as the tool to use to serve static files. It would do it with much more performance than PHP-PM. But what it does also make it useful for, and what some of those features are for, is that you can use it as a development server, because you can just start PHP-PM and it will automatically take care of your static files and when you change your code, which is quite useful. And in a lot of the development environments, Symfony are quite slow, so having the application in line between requests can be a handy feature. Installing it is relatively simple. You clone the Git repository, run a composer install, and then link it into your local binary directory. You could then go into your Symfony project, install the HTTP kernel adapter, and then you can run that ppm command, telling it it's going to bootstrap to Symfony. And there's some other things that you can do along the way. So here you can say I want 20 different workers. You can obviously set the environment that you want to boot your Symfony kernel in. And there are other features and flags that you can use to customize the behavior of PHP-PM. So it's quite simple to get going. The other alternative is actually a piece of software that I've worked on. I've worked on it for a long time. Is a program called PHP-FastCGI. This is different because it's not turning your application into a web server. It's turning your application into a fast CGI application, which is also a server, but it's different to a web server. It's not something that you could use public-facing. It's quite easy to install as a bundle. You just install it as a bundle. It will add a console command to your application. There are adapters for Silex, Slim, and Zend Expressive if you're interested in those too. And it has a feature for automatic shutdown mode where it will automatically shut down a worker if it receives a 5xx error code, which is something I'll touch on later as well. Again, installing it, you've all installed bundles before, so to compose or acquire the bundle. It's called the Speedfony bundle because I'm great with naming things. Simply add it to your registered bundles, and then you can start it up. And again, it's got command line. You can choose which environment you run it in. You can make it listen on a port. You can also set it to run on Unix file sockets as well. And configuring both of these with your web servers quite simple, really. You can use Apache with both of these, but if you're really that concerned about performance, you're probably not using Apache as the web server for this type of setup. What you're probably using is Nginx. If you'd go onto the Symfony documentation, there is a very useful file which shows the minimal configuration that you need for different web servers. So it has an example configuration file for Nginx with PHPFPM. And with PHPFastCGI, that file is almost identical. The difference is that you can create a little cluster of upstream workers. And in the before, where you had the Unix file socket for PHPFPM, you replace that with a FastCGI pass-through to your worker cluster. And then Nginx will automatically load balance between those servers. That's again quite similar for PHP-PM. There's a slight difference here because you have to add some proxy headers. Adding those proxy headers means that in Symfony you have to set the local host or whatever the server is as a trusted proxy to get it to handle IPs properly and securely. But in general, the configuration for these is no more difficult than when you normally use PHPFPM on an Nginx server. Just a little bit of a comparison between the two. I am the author of the latter, so full disclosure here. What you're comparing is HTTP against FastCGI. They are completely different protocols. HTTP actually means that the server will receive the full request as it's sent, so you'll get all of the headers as they're originally sent and the body as well. FastCGI, the server has gone through that request and passed it into a set of variables for you. That does a couple of things. That means that you don't actually receive the headers as they were, which is something you'll notice if you ever use PHP-PM. What you actually receive is the headers that it's decided to pass through to you in your server configuration. It's also, I think FastCGI is probably possible a little bit securer because you have a web server in front of you that's filtering the requests, whereas with HTTP, it's proxying them to you. PHP-PM is much more popular. PHP-FastCGI, I do get pull requests and issues and things all the time, and people are using it, but it doesn't compare to PHP-PM. There are a lot more people using PHP-PM. And PHP-PM is based on React PHP. And as I said earlier, that doesn't give you any asynchronous benefits, but what that does mean is that if you want to use like an extension, such as libuv or one of the event extensions, you can actually switch out the React event loop for something much quicker and gain performance that way too. So how much faster is this process? I've been talking to you a lot about the actual concept of keeping the application alive between requests, but what kind of performance increase could you expect to see? I created a little benchmarking application. It's a 500-page Symfony application. It selects a root, just a random page from the database, renders it using Twig, clears the entity repository after each request, which just means that it's not caching SQL, so it's still performing an SQL request every time. And if you want, I'll put these slides up at the end. I'm not going to spend too much talking about this, but that was the benchmarking system that I used. I created a control test which had the OPcache enabled. You can have the OPcache enabled in a few different modes. The most aggressive mode that you can put the OPcache in is it will not even check to see if your files have been modified. So once it's cached your PHP files, it will not check them to see if they've been remodified. You can have timestamp checking. I have heard that there's little difference between these two modes, but the most aggressive one for sure, it doesn't actually do any hard, if your application is cached, it will not actually touch the hard disk to serve a response with the OPcache enabled. And PHP-PM. So what I tried to do was just make this application as fast as I could without using any other techniques. The first test that I used, I had 6 worker processes with the FastCGI protocol implemented in PHP useland. And what that means is that the FastCGI server is the version that's written in PHP. There is also an experimental extension, which I tested. And what that does is that uses a FastCGI extension, which I wrote, which binds into the FastCGI C library and does all that processing in C, which is a lot quicker. The results before I did that, I was getting about 283 requests per second with PHP-FPM. With the FastCGI program written in PHP, I got about 1,300, and with it written with the FastCGI extension, which is the same API, just a different backend, I got 1,770 requests a second. So it's a performance speed up that you simply cannot achieve generally through other means. Obviously, you can do things like caching, but if you have dynamic data, it's very, very hard to reach the performance that you can with this. I have not got any PHP-PM benchmarks. There are PHP-PM benchmarks on their website. I think it's quite, I'm not sure if it's quite a bit or a little bit faster. The applications do different things and have different features, so it's not a straight comparison. But you get the same sorts of speed ups using either of this software, and you can generally make your application many, many, many multiples faster. But that's not the end of the talk, because there's a lot more to doing this than what I've just told you. What I've just glossed over was the good bit, the lovely fast performance application that we got doing very little work. The problems in paradise, the first one that I'm going to come to is memory leaks. This is something that in PHP we generally don't have to have much concern about. There are examples where we have concern about memory leaks. Show of hands, who's ever programmed in a language where they had to manage their own memory? Very good. Task. join two strings together. This is something that in PHP is very simple. In C, it's a little bit different. That's a function that I've created in C. This does what you can do in one line of PHP, and this is the reason that no one uses C. You have two strings as functions to your arguments. You need to measure the length of each one, add them together, add a 1 on the end for a null terminator, make a memory allocation request to the operating system, check that to make sure it's not null so you're not writing to a null pointer, copy the first string into that buffer that you've just allocated, and then add the second string on the end and then return it. Very simple. Once you've joined your strings, you can do stuff with it, and then you can free your string. The benefit of this is that it's very, very clear how I can shut down on memory leaks. It's very clear where I request memory, it's on that malloc call, and it's very clear where I return that memory, it's on that free call. So I can shut down memory leaks just by making sure that for every time I request memory from the operating system, I then free it. Now in PHP, joining strings is a lot more simple. I just do that. Now, I've clearly allocated more memory because I've created a new variable that I didn't have before. But how do I free it? How do I know when that memory has gone? Now, that's something you actually need to understand a bit about how PHP, the interpreter, works before you can proceed. So how would we keep our application clean with memory? PHP counts references to variables. Internally inside PHP, there is something referencing each variable called a ref count. And what that does is that keeps track of whether your variable is in scope or not. So in that function that I've got there, the string variable is in scope within the scope of the sumRoutine function. As soon as I leave that function block, the reference count to that variable is decreased to 0, and PHP can come along and collect the garbage. There are some examples where it has to, if you have things like circular references, where it will have to run circular reference collection routines. But in general, once the reference count reaches 0, the PHP will free the memory. So the simple answer to this is that what we need to do is remove references to variables to free the memory. So we can also use things like unset. That's it. We have to remove references to objects that we don't require anymore. Can anyone think of things in Symfony that might hide references to objects? Any shout-outs from around the room? Pardon? The double dollar? No, I'm talking more about Symfony components or bundles or features of Symfony. Yeah. Pardon? Can't hear, sorry. I can't, sorry, I'll move on anyway. Doctrine ORM is the one I was going to go with first. I don't know if that was what you shouted out. The entity manager in Doctrine, or the entity or an entity repository, will actually manage, it manages your entities, which means that if I made 2 requests to a repository to find an object, it wouldn't actually hit an SQL query or a query on the second time, because it's already got that entity in memory. So what Doctrine will do is actually cache that in memory, and it won't forget it until you do something like call the entity manager detach function, or if you call entity manager clear. Now, this isn't something that we usually need to worry about, and you very rarely see controller code or business logic code where people detach entities because they know that they only need to do that once, and that at the end of the program, it's all going to get wiped anyway. That's all well and good if you're running PHP in shared nothing architecture, but if you're running PHP and keeping Symfony alive between requests, you can't take that approach. So one of the things that you need to be careful of is entities that you've loaded from Doctrine and how long you're remembering them for. Another program that hides memory allocation, hides references in Symfony is Monologue. And the fingers crossed handler, for those of you that haven't heard of it, I think it's a brilliant name for a handler. What it does is it will log everything, and it will keep its fingers crossed that nothing bad happens. Because when you're logging, it's not just useful to know what errors happened, it's useful to know what happened before the error message. So fingers crossed handler will record all of the logs that come into it, all of the notices and things like that, and then if there's an error, it will write to the logs everything that happened before the error, which is useful because you can see the build-up to the situation which caused your error. However, in a long-running application, if you don't have an error, what happens is that log just keeps on recording and recording and recording all of the notices that you've had in your application, and that causes a memory leak. So one of the things that you can do is you can set on fingers crossed handler a limit, so you can say how many logs it will store. And another thing you can do is you can clear it. But again, not something that you normally would have to consider doing. Another approach to memory leaks is that you can kill down your workers after they've been up for a certain amount of time. If you've ever written like RabbitMQ consumers, it might be common that you say that each one will process a certain number of messages, and you can do the same thing with PHP-PM and PHPFastCGI. I don't consider this a design tactic, more like a bolt and braces solution that you can use so that you don't get bitten. I would say generally you should try and remove memory leaks, and that this is a feature that you can make use of if you need it. PHPFastCGI also supports memory and time limits, so you can say once you go above a certain memory limit, it will kill the process, and you can also say I will not want my workers to be alive for more than 5 minutes each. I created last night, so work in progress, the No More Leaks bundle. I don't have anything against the vegetable, this is memory leaks only. And what you can do with this is it will automatically bind an event listener, a very low priority event listener, to the kernel terminate event. And what it will do is it will go into monologue, and well, however you configure it, and it will go through the channels and traverse the handlers, clearing memory along the way. And there's also a doctrine event listener that will clear the entity manager and some of the doctrine SQL logs as well. That might also be useful, again, I've mentioned RabbitMQ a few times. If you have any workers or long-living processes in PHP, that bundle may be useful to you. It's a work in progress, so it'll be developing over the next couple of weeks, hopefully. Another problem that we can face with Symfony applications is timeouts. Have any of you ever seen that error before? Yeah. Long-running processes, I often get this kind of error, and it's a particularly nasty error, because while you're testing your application, this error doesn't exist. This error is nowhere to be seen. Whenever you're testing your application, all of your application instances are a few minutes live or whatever, and everything's hunky-dory. As soon as you deploy it to live, and then your site gets quiet at 2 or 3 o'clock in the morning, this error rears its ugly head. And it happens in the form of connection timeouts. Doctrine has a feature which you can use to prevent this. I would like to see Doctrine able to restart connections automatically if they've been timed out, but I'm not sure if that's possible. I'm sure there's a reason they haven't done it. But you can ping a connection before you use it, and if that connection's not alive, you can close and reconnect that connection. The other option is you can configure MySQL timeouts differently. And another thing that you can do is you can configure, as I said in PHPFastCGI, you can say I don't want applications to live beyond the SQL timeout limit. Error handling. So this is another one that can bite you, and this is because errors are traditionally caught by your application, especially Symfony. Symfony will catch all exceptions that happen. There's a distinction to be made between request errors and application errors. Symfony catches all of your errors because there's no reason for them to propagate through the stack. It's much nicer to present your proper error page however you've designed it. But with keeping your process alive, you do need to distinguish, because the connection timeout error that we've just seen, that's an application error. If you get a connection timeout error, you need to restart that application. There are some errors which will cause you to want to reboot your workers. And there are some errors, which are like 404 errors, where you couldn't care. That's a user error. Your application is not broken. You need it to stay alive. So the distinction between request and application errors becomes even more important. And we can do that through HTTP status codes. So a 4XX error code is a request error, and a 5XX error code is an application error. We need to let the application die and the worker restart if we can't recover it. PHPFastCGI has an auto shutdown mode for 5XX error codes, which means that if you start it with an auto shutdown flag, if you return a 5XX error code, that worker will then die and then get brought back up again. Whether or not you use that is probably down to your own application logic. You can also trigger internal, you can flag the application for shutdown and restart. I was going to submit a pull request to PHP-PM to do a similar thing as well. So it's both of these pieces of software are being developed on in active development, and I'm sure there's an alternative in PHP-PM for doing something similar. Sessions is one of the last things that can bite you. The evil session superglobal. This is probably my least favorite part of PHP. I hate this superglobal more than I could convey to you. Session start and all of those functions I would happily remove. What Symfony does natively is it will just wrap that session superglobal. So Symfony out of the box, sessions will not work. In fact, it will carry on sessions between requests. This is obviously very, very bad. PHP-PM has a handler for regenerating sessions. And what that will allow you to do is regenerate sessions between requests, and it will reset the session IDs. I actually had a look at the handler, and there is a bit of a problem because on lots of servers, you don't actually want to always start a session. So you have to take care to make sure that you don't always start sessions and that you only restart a session if you need to. Because every time you use the session functions, PHP will automatically start a session. And if you only need, say, 10% of the clients to your website to be using session management, then that can cause a problem because suddenly you've got a lot less storage space for sessions. So in general, I think anything that hits the session superglobal is sort of like a nasty hack that should, you might do it and it might work for your application, and it's useful to know that you can do it if portability is very important. I would consider rolling your own here. There are PSR 7 session libraries, and you can store sessions and data and things like cookies and other headers. It's a good opportunity to investigate if you've got the time to, because with more and more people trying to keep their applications live between requests, bundles and things that make this easier to do and more compatible will definitely be welcome in the ecosystem. But it's worth noting that sessions are a problem area and will not work as they have done before when your application is run in this way. Sort of coming towards conclusions here, do you really need these tools? A lot of people's applications are fast enough already. Most of the applications that I've ever worked on, the response happened relatively quickly. The application just was fast enough already. I didn't need to do this. Doing this is a risk. If your application is already working and you're changing it, you're making a risk. There's a chance that something will go wrong, that you'll lose time, and time is also known as money. So if your application is already fast enough, this isn't the right thing for you. Where I've seen these sorts of tools come in handy, there are some developers that I've spoken to after talks who their teams have had to hire Scala developers to create a low latency piece of a low latency HTTP application. And once they've hired this expensive Scala contractor, they don't know how to maintain the code, and they've got to pay for another one to come back in when they need to make a change, because the tools to have this kind of high performance PHP script just weren't available. This PHPFastCGI and PHP-PM are tools for high performance applications. This isn't for your everyday application, although it'd be lovely because things like Node.js already run in this way. If the ecosystem could get to a point where this was less risky, this is a way of creating an application that's much faster than any other way of creating an application, but also much riskier. Reflecting though, a well-designed application shouldn't leak memory. We should know when our application is requesting memory and when it's releasing it. We should be handling our errors properly. We should be distinguishing between application errors and request errors already. And it's quite an easy process to perform with Symfony. I've created Symfony apps to run in this way with very little time investment at all. It's sometimes as simple as just adding a bundle. If I knew when I was creating the application that I was going to run it in this way. In conclusion, when you're writing code, consider consider components and services might want to use that code in this kind of way. So it's not the case that in 5 years' time we can guarantee that all PHP applications will be run in a shared nothing architecture. The demand and use of these applications is increasing, and it might be a decision that you decide to make in a few years. So when you're creating components and services, just consider that long-running processes might want to use them. That might not even be inside a web stack. That could be inside, as I said, worker processes on a job queue. It might be that they want to use your code and they don't want your code to have memory leaks. So be aware of how you can not leak memory in your code. FastCGI and HTTP are designed to allow applications to stay alive between requests. PHP kind of isn't designed to allow applications to stay alive between requests, which is why this is a little bit risky and why it's a bit new and a bit scary. But as I said, if you use this technique on your application, you'll reach a performance that you simply can't achieve using other conventional speed-up tactics. I don't know if I've got time for questions. I know we're a bit late starting on. There's a joined-in link that I'd really appreciate if you could rate this talk, and a few links at the bottom. Thank you all for listening carefully, and if you've got any questions, you can either fire them out. Have I got time for questions? I've got time for questions. Has anyone got questions? No one's got any. Thank you very much, and hopefully I'll see you around the conference.